Before I talk about this video, I have a question for you. How often do you use debuggers with your code in execution to analyze it and identify the pieces of code which are not working the way you expected them to? If the answer is not always, then this video is for you. We have prepared a series of videos on using debuggers in IntelliJ IDEA, and in this video I'll cover basic and advanced stepping, which is one of the most basic ways to step along the code in execution and find issues with it. Before we talk about how to debug this piece of code, let's understand what the code is about, what we expect it to do, and where it fails. In class process student data, I have defined a main method, and here I define a list of students. Class student is a plain data class in which I define two instance variables: constructor, get ID, get name method, and a toString method. Nothing fancy here. Let's go back to the process student data class. Now the next two lines of code create two instances of class student and add them to the students list which we just created. In the next line of code, the fix spelling error in student list method, as the name suggests, tries to modify the list student by searching for a student which has the ID 1, the old name, and tries to replace that with the new name which has the correct spelling. And at the end, it prints out the value of the student list. Now let's dive into the definition of the method fix spelling error in student list. Now it creates an instance of the student class, and then it calls the index of method on the list student list. If the student list is able to find this instance in itself, it will return the index for the first occurrence for this instance. And now moving on to the next line of code, if of course the index value is not equal to -1, which means that it has found the element, what this line of code tries to do, again, it creates an instance with the new values, which is the ID and the correct name, and then it calls the set method on the student list, replacing the old instance with the new instance with, of course, the correct name. Now let's run this code and see if it does what we expect it to. What do you expect it to? Comment below and let me know. So let me run this code and see if I get an updated list with the new name. No, I don't. As you can see here, this name is still the old one with the spelling mistake. So it's time to debug our code. It has started raining here, and that has completely changed the lighting in this room, as you can see in the video. Now back to debugging the code. First of all, let me close the run window and let me go to the main method and set a breakpoint on this line of code. By setting a breakpoint, I can control how and when my code executes in the debug mode. Now let's start the execution of this code in debug mode. The code execution pauses at the breakpoint. So how do I execute the rest of the code? One of the basic steppings is step over, which means execute the highlighted line of code with the background blue and go to the next line of code without deep diving into any of the method calls which are present on the highlighted line. Are there any other method calls on this line? Yes, there are. I can see the constructor of an array list being called on this line, which I don't think I want to deep dive into. How do I step over? I can either use the shortcut F8 or I can use the icons here. Let me start with using the icons, which is step over F8 here, and then I move to the next line of code. You can also view the variables that are created due to the execution of this line of code. You can also view these variables in the debug window here, but it just makes easy if you are trying to figure out which variables were created and what their values are. And you can see the same values and the same variable names both in your editor pane and in your debug window. Now let's step into one of the method calls in the highlighted line of code. And which one is that? You guessed it right. That's the constructor for the student class. Now I can use step into icon here, and that would take me to the definition of the constructor of this method. And again, I can step over and see how the constructor of the student class is being called, the variables that have been assigned I can use step out to exit this method call, but since I'm already at the line at the end of the method, if I press step over or step out, it will eventually take me out of this method call. So let me use step out. The next is step over again. I have two variables, which is two student instances with ID1 and ID2, name as I specified here, are being created. Students.add student1 adds a student to the list. The size is still 0 here because we're still on this line. We have to use the step over command so that the size changes to 1. Let me show that to you. Now when I step over, now I see the student list being populated with one item. If I step over again, that would be 2 items in this list. As you can see, students array has size 2 now. If you scroll here further, students array list has size 2. Now, when I'm on this line of code, I want to step into this method. Now I will use step into. When I am in this method, first of all, I want to figure out what is the value of the variable index after this line of code executes. Because if this is -1, then I might have to deep dive into the other methods which are present on this line of code. So step over, and the value of index is -1. So how do I go back to the previous line? What I can do is I can drop a frame here, which is another basic stepping method in which I can reset the frame or drop the frame. Here you can see the stack of method calls, and I could drop one, reset the frame, and go back to the other frame. Let me do that. When I reset this one, I go back to the main method, and now I can again step into, because I know that it returns -1. What I want to do is I want to step into the methods which are present on this line of code. At this point, you would see that there are 2 methods being highlighted, which is smart step into, which means that there are multiple methods that I can deep dive into and examine the code. So I've already examined the code for the constructor of the class student. Now what I want to do is I want to deep dive into the code of index of, which is the method from the Java API. Yes, you can examine the code, whether it's your own code base or the code from any other API. Of course, the IDE decompiles the code for you. Then you can use the stepping methods and examine that code as well. I can use the mouse and click into index of to go to that method, or I can also use tab. If I use tab, I can select which method I want to go to. Let me select index of. And now what I see is this method calls another local method, and I want to see what's in that method. So in this case, I'll step into this method again. This takes me to another method. I'll use step over. This object ES has a value. So the code, the control will go to the else block, because this is not null. If I use step over again, I can see that this goes here. And now what I see is that this array list is trying to match a value from its starting position to its end position. And now it goes into the comparison here. Now let me go to step over. I can see the variable values here, which is student ID1 and the name Harry, of course, with the incorrect spelling. Now this should return true according to my logic. Let's see what happens. If I step over again, if this goes here, my logic was correct. If it doesn't, my logic wasn't. When I step over again, I see that it did not go to this line of code, which means that my logic was incorrect. Can I go back to the previous frame? Yes, I can. Let me drop this frame again, and let me step into this method again. I step over and go to the next line of code, step over to go to this line of code, and I will not step over, I will step into to see what happens here to see what exactly is being called, the method that is being executed here. And I step into, and this is where I go. And let me turn my tab placement so that you can see the name of the class I'm in. Now you can see that I'm in the object class now. When I'm trying to compare two values in an array list, it takes me to the equals method of the object class. Wait a minute, did I override my equals method in the student class? I think I did not. What I also could do is I could change the value that I return from this method. And how can I do that? I right click on equals here and I say force return. What do I want to return? Let's say I want to return a true value. And if I do, then this method return a true value, and now the code control will go to this line number. Let's see if it does. So I can say step over and I can say the value goes here. And that really means that I need to override the equals method in my main code. So let's do one thing. Let's stop this debugging session and go back, close this debugger window. Now let me go to the student class of stepping, and in this case let me just override, let me add the equals method here, and I'm using my IDE to generate this method. And if I go back to process student data, and let's see if I run the code, would this return me the right value? Now let's see. Yes, it does. If you look at this code here, you can see that I get the IDE 1 and the correct array name here. So we did manage to debug our code, and in the process we used multiple stepping techniques, which is step over, step into, step out, force return, reset frame. The next stepping technique that I want to talk about is run to cursor. It comes in really handy when you are stepping into, let's say, a long method and you do not want to step through each and every line of code. You want to skip, let's say, a block of code and run to the line where your cursor is, because there is where you see some interesting code happening. Let's use it in an example. In this example, I'm using the Faker API to populate a list of students. I start by creating an instance of Faker, and then I use its method full name, which is called on name method, to get names which make more sense, and then I use those names to populate my list. In this example, I'm not trying to debug my code or find any problems. What I'm interested is in analyzing my code. I want to figure out what happens when this method call is made, or when my code creates an instance of Faker. I'm just curious. So let me set a breakpoint here, and now let me start with the debug process, and my code will start at the breakpoint which I just set. And I want to, of course, step into this method, and this takes me to the decompiled code. You can see here it's a decompiled class. I want to again step into this method because at present this doesn't give me a lot of information. So I step into this method again, and again I want to step into this method again, and I get a choice which method do I want to step into. That's again a step into, and now I can see creation a lot of other instances here, and now I could step over and see where the full name is. If I could also scroll and find where the name or full name values are. Let's see if I can find them, or I could also search for that. Okay, so this is where name is, and let's see where my current debug control is. I can run to a line which is ahead of execution. If I place my cursor here and then I say run to cursor, then it will not work and my debug session will stop. I can move forward and I want to skip execution of all these one by one. They would execute, but I don't have to step over them one by one. Now I can put my cursor here and I can say run to cursor. And now when this happens, you'll see the execution is on this line. All the previous variables you can see in the editor pane. So this is how you use run to cursor. Another advanced stepping technique is the ability to throw an exception from either your own method or from a method which has been defined in another API. For an example, let's go back to our debug session, and in the debug window, I can right click on a method frame here and make it throw an exception. I can say new runtime exception and see what happens. And I can see what happens when that exception is thrown from the method that I just modified. This feature can help you work with cases when your code doesn't throw an exception, but you would like to figure out how the code will behave when it throws any certain type of exception. The last stepping technique that I want to talk about is jump to line. In the previous technique, run to cursor, I mentioned that you can only move forward in your code when you're debugging it by using run to cursor. And in one of the previous techniques, which was reset frame, I talked about how you could drop a method stack so that you could move to the previous method and then you could move forward by stepping into or stepping over. Now, jump to line is an interesting stepping feature which is available via a plugin. So let me show that plugin to you. So I just installed that plugin on my system to use this stepping feature. And what it does, that it allows you to, as I mentioned, move both forward and backward in your code when you are debugging it. It's a really powerful feature, but also has disadvantages to it. For example, if you try to move forward to a line by skipping a few lines of code, it might not execute all of those lines, and that might result in a behavior that you do not expect. Let me show you an example. So again, let me debug the same code that I used in my previous example. And now when I debug it and the code stops on this line of code where I've set the breakpoint, I would also see a yellow arrow, which is due to the plugin jump to line that I just installed. And now instead of stepping over or stepping into, if I just move my, if I move this yellow cursor, let's say to this line of code, what I see is the faker is null here. So yes, I do get the benefit that I skip a few lines of code, but it could also generate some results which are unexpected. And now if I go back here, I could say step over, faker has some value, and let's say then I want to skip to this line, and I don't want to add a lot of instances, and I want to skip this part of code, and I just want to add a student instance which is a result of this part of code. In this video, I covered multiple stepping techniques to help you debug your code or to analyze it. I covered basic stepping techniques such as stepping over a line of code, stepping into a method, stepping out of it, running to cursor, dropping or resetting a frame. I also talked about multiple advanced stepping techniques like forcefully returning a value from a method, returning an exception from a method, which it doesn't in the code, and also jumping to a line either forward or backward. I really hope that all these stepping techniques help you to debug your code. If they do, don't miss to comment on the video below and let me know how it does. And thanks for watching.